Okay, here we go. Let's have a look.
You shouldn't.
Okay, real quick. Better or worse? Is that too dark, right? Okay. All right, so let's plan our proof here. What are we trying to do? So we're trying to show we're given 5 and 6 are congruent. We're trying to show that 4 and 7 are congruent, right? Okay? So stare at that for a second. Let's come up with a strategy. Any ideas? What do you do this? Katie, you have an idea. What do you think?
Well, given first.
Okay, so we've given first. All right, so first thing is we know that angle 5 is congruent to angle 6. Given. Okay, what do you think?
Angle 4 is congruent to angle 5.
Okay, so why is that?
Vertical angle is 0.
Okay, good. So now that's fine. What you might want to add first though is that 4 and 5 are vertical angles.
Okay.
Why do you think that would be? Okay, good. Definition of vertical angles.
Yeah.
Right? Okay, so let's combine 2 and 1 here. What if we said angle 4 and angle 5 are vertical angles, and what else at the same time might I do? 6 and being is it's an identical step, let's just include it in one step. So angle 6 and angle 7 are vertical angles, and my reason for that we said was definition of vertical angles. Good. Okay, and then and you also had the step then that angle 4 is congruent to angle 5 and angle 6 is congruent to angle 7. What was our reason for that?
Vertical angles theorem.
Yeah, good. Vertical angles theorem, which just says all vertical angles are congruent. So okay. So look what we've done here then. We've said that these two are congruent, right? Those two are congruent to each other, and those two are congruent to each other, right? So what can we do? Suggestions? Oh, you got an idea?
Since 5 and 6 are congruent, you could switch them. You could switch any of them.
Okay. No, that's good. You're onto something here. So we could say. I'll roll this up a little bit. We could say that because 5 is congruent to 6, 4 is congruent to 5, and 5 is congruent to 6, we could therefore say 4 is congruent to 6. I know, we're not quite there though, right? So 4 is congruent to 6, and what's my reason for that? Transitive. Transitive property of congruence this time, right? Not equality. Good. And then the final step.
6 and 7.
Yeah, we know that 6 and 7 are congruent, and so if 4 is congruent to 6 and 6 is congruent to 7, then 4 is
Congruent to 7.
And what, of course, is my reason for that?
Same thing.
Same thing we had there, right? Okay. Make sense?
Mhm.
Okay. All right. One more.
Wait, so
Yeah, question.
on the general ones, can that be congruent instead of equality on all of them?
Yeah, it does. In fact, I think they're on there. Yeah, they should be on there. If you look.
I would not do it.
Okay.
What is the little, squiggly thing over the equal sign again?
This is equals. Oops. This is equals, and this is congruence. Okay, and what's the difference?
One
That's
is
equal
a
as
number,
numbers.
one's a value.
Emma? Go ahead. Go ahead.
Equal as numbers.
Yeah.
Like degrees.
Okay.
Sorry.
Okay, good. You can set anything that could have a value equal, but things have to be congruent, right? Like geometric things, things that you would draw.
You make something like congruent to something, like over.
No, go ahead.
So could it be like angle 4 plus x is congruent to angle 6 minus x or something like that?
No, where x is just a variable?
Yeah.
Can't really do that, because that'd be like saying an angle, x would have a value, right? Like it could have a certain measure, it could be 30 or something, right? But an angle, that's not what an angle is. An angle is something, an angle is an actual thing, right? See what I'm saying? So you couldn't do that. You could say, does that make sense?
Yeah, it does.
Okay. You could say the measure of angle 4 plus x equals the measure of angle 7 or something, because those are all values. Yes, sir?
So essentially we're saying the same thing, but equals from a algebraic perspective, congruent is from a geometry.
Exactly. That's it. Anything that, a geometric thing, something you would have to draw would be something, that's something you have to be congruent. Okay? All right, so next one. One more. This was a little,
This one,
yeah, this was a little bigger one.
37.
37, yeah.
Is that the one where we could put Reeves jumping in Gold Lake?
Yes.
Maybe, yeah.
Yeah, I remember that, that was hilarious.
The lady do. What? Did you put that one down? That's it. I clicked yes, just to say. Oh my god. One. Whatever. Imagination. Oh, yeah. Oh, I have that one. Oh, you got 37.
Yes. Yeah. I basically said that's my angle.
How are you? How are you taller than me? It was really dumb. Super You don't go, oh. Oh, this one? Barely right. It is actually barely. You're still He's taller than me.
Okay, let's have a look. So there's the picture.
It's beautiful.
Beautiful picture, I agree. We're given that the measure of angle ZYQ, and we could even draw this in here if we want to. ZYQ, so that's this guy right here, right? That's 45 degrees. And we're given that the measure of angle ZQP is 45 degrees. And we're supposed to prove this, that ZQR, so that angle is congruent to XYQ, so that angle. That's what we've got to prove, right? This is a pretty good problem. It's a little tougher. So what are some things maybe that we could do here? Let's kind of throw out some ideas. Elimination, what do you think?
Just write down the given.
Okay.
And then set angle Z QP and go to angle Z Q.
Okay. So we're gonna try to show, so the suggestion is, if we could do this, if we could show that this angle is congruent to that angle, okay, that might help, right? Any ideas from there, what we could do? Emma, what do you think?
I said that ZYQ and XYQ are supplementary.
Okay, so so this angle and this angle are supplementary. We need to maybe show that, right? And then what else? Oh,
Take the measure of XYQ, plus 45 equals 180, and then subtract 45 from that. I'll give you the measure of that.
Okay, you could,
Do the
sure.
same thing to the other angle.
Okay, that's a way to do it. That would work. But we might even be able to maybe even do it a little quicker. We may not even need to get the actual measure. Daphne, you have an idea?
Question, is it a right angle, in like point Z a right angle?
Okay, you answer me. Is it a right angle?
We don't know.
We don't know. So can we assume that?
So we can't assume that it's 180,
We cannot assume
that X, Y, Q,
that XYQ.
and Y.
Well, if they're on a straight line.
Okay, we can't assume that because if it's maybe we can assume that. Now the suggestion was, let's kind of get back on track with where we were. So suggestion was made, can we show that these two angles there and there are supplementary? And I would say that yes, we can. I mean, we can't just state it. We have to kind of verify that. We kind of build towards that. There's a few other steps that we would need to include to justify that statement. But yes, we could get there. Is there another pair of angles that, what do you think, Katie?
ZQP.
Okay, so this one and that one?
Yeah.
Good, so we could also show that those two angles are supplementary. Now, if we can do that, think what we just said. If we could get to that point, this proof would be essentially done, wouldn't it? Because if we know that this angle that we're trying to show is congruent to this one, right? So if angle XYQ is supplementary with this 45-degree angle, and angle ZQR is supplementary with this 45-degree angle, if we could just show that those two angles were congruent, those 45-degree angles, which is pretty easy to do, then how could we justify the proof? The last statement would just be that, yeah, the two red angles are congruent. Why? What would be that last step? No? That's it, the congruent supplements theorem, right? Think about the congruent supplements theorem. And I don't expect you to memorize all these, but we talked about that one a lot yesterday. Do you remember what that one is? If two angles are congruent to, or excuse me, are supplementary with the same angle or congruent angles, then those angles are congruent. Yeah, right? So if we could show that the green angles are congruent, and each of these red angles is supplementary with a green angle, then by the congruent supplements theorem, the red angles have to be congruent, right? So there's the skeleton of our proof. We just need to kind of add all the little necessary steps to that, right? So what were the things we had to do? Well, one thing we had to show is that the green angles were congruent, right? The other things we had to show were that the pairs of red and green angles were each supplementary, right? And if we could just get to there by the congruent supplements theorem, we're done. So let's see if we can do that. So the suggestion was, first, given, right? Oops. Step one. So how about if we first, let's tackle the green angles. You gotta show they're congruent. So what could we do? Okay, I mean, it's a stretch, maybe, but could we do one thing that would make it a slam dunk, that makes it indisputable that we got it? What do you think the step immediately preceding? If I want to say that angle A is congruent to angle B, for example, what do I probably need to have right before that? You say it again? No, okay, no, I mean, but what's the step? If the next step is the measure of angle A, or excuse me, I just gave you one. If angle A is congruent to angle B, what's the step maybe right before that? Okay, good. Measure of angle A equals measure of angle B, right? And then by the definition of congruent angles, they would be congruent, right? Agreed?
Agreed.
Okay, so what would probably our next step be then?
CYQ, CQ.
Have the same measure. Their measures are equal, right? Does that make sense? Okay, so then step two, we could set, this one is equal to that one. Measure of angle ZYQ equals the measure of angle ZQP. And what's my reason for that? If the measure of angle ZYQ equals 45 degrees and 45 degrees equals the measure of ZQP, then transitive? I mean, probably you could also say substitution, but didn't we say we're going to kind of just stick with transitive in those situations? Transitive property of equality, right? Okay, so then the step that maybe goes with that, what's the next step?
ZYQ is equal to ZQ.
Not equal. Congruent. Angle ZYQ is congruent to angle ZQP by good definition of congruent angles. Good, right? So far so good. So we showed those are congruent. Now we just need to show that these are each supplementary, right? And maybe we could even group these steps together, like big steps. So how am I going to do that? Let's talk about how I'm going to show, for example, that these two angles up here are supplementary. What do I probably have to do first? What do you think, Kurt? Okay, they're a linear pair. There you go. So angle, we could say maybe angle, what is that? X, Y, Q. And angle ZYQ are linear pair. And while we're at it, what other two maybe?
ZQP and ZQR.
Good. Angle ZQP and angle ZQR. What's my reason for that? Definition of a linear pair, right? Okay, so if they're a linear pair, then what about them? They're supplementary. There you go. So angle X, YQ, and angle ZQR are supplementary, and angle ZQP and angle ZQR are supplementary. And
Isn't ZYQ on the top one?
did I get it wrong?
Yeah, put ZQR.
Oh, I put ZQR, ZYQ, you're right.
You already have ZYQ. What do you mean? XYQ? Wait, no.
No,
Never mind.
XYQ and ZYQ. Okay, and what was my reason for that? Linear pair postulate. Okay, and so now we're done, pretty much, aren't we? Now we can just say our final step. We can now say that angle, what are the two angles we're trying to get? Angle ZQR and XYQ are congruent. Right? Because if ZYQ is supplementary with XYQ and, hang on, did I get that wrong? No, that's, okay, if XYQ and ZYQ are supplementary and ZQR and ZQP are supplementary, but we already said that these two are congruent, right? Then by the congruent supplements theorem, we know that those guys have to be congruent. Right? Make sense? Yes, sir.
On the test, why would we like accidentally switch a step? It's not like you didn't.
Oh, it wouldn't makes no difference. Like, for example, the green steps could have been switched with the blue steps and it still would be fine. Right? Does that make sense? No, that's fine, because really, does everybody agree that the green steps and the blue steps combine to give us the final red step, right? But those could have been in any order, it wouldn't matter. Yeah. Okay, that makes sense?
Is this as hard as it's gonna be on the test?
Oh, yeah. That's a pretty hard one, I think. I mean, it's
very hard.
Okay. So, does that make sense how you prove they're supplementary? You gotta say that they're a linear pair and then you know if they're a linear pair, then they're supplementary. Yeah. Now, if you just, so once again, if you had maybe skipped that step 4, and just gone right to step 5, you know, you'd get a lot of credit for that because you still saw how to do the proof, but you just missed the justification of one step, right? To get 100%, it'd have to be like that. Okay. All right, so here's my question to you then. We've gone through the proofs. We have some options for the rest of the period here. Do you have questions? Do you want to go through questions on the assignments? Okay, is that reasonable? Okay. So, what questions? I'll pull up the textbooks. You tell me which assignment are we looking at first? Yes. 2.5. Okay. Okay, what questions on 2.5? 27, all right. Oh yeah, this is a good one. I really like this one. Yeah, I'm not going to help you a ton, but I'll get you started on this one. Okay, so all right, so this is the one. Now we're going to say that M is the midpoint of segment AB. P is the midpoint of segment AM. Q is the midpoint of segment PM. So here's what we're saying now. This, I can see where maybe this is a little confusing when they say this. If A and B are the coordinates of points A and B on a number line, find the coordinates of P and Q, right? So if we had to draw a picture on this, wouldn't it just be something like, there's our number line, right? Here's point A, and there's point B. The coordinates that go with that are little a and little b, right? So let's just do the midpoint, and you guys will have to take it from there. So the midpoint M is right there, isn't it? Okay? Anybody, okay, so what's the distance between, what's the length of segment AB?
B minus A.
Okay, now, it's confusing because there were two answers there, and both were potentially right. So what I'm saying is, yes, that distance equals what? B minus A. It does, doesn't it? Think about it in terms of numbers. What if A were 3, for example? Let's just say hypothetically that A was 3 and B was 11. What would be the length of that segment? Everybody would tell me 8, right? How'd you get it? 11 minus 3, right? Okay, I want the coordinate of the midpoint. Now let's first of all tell me the coordinate of the midpoint, assuming the green information. If A has coordinate 3 and B has coordinate 11, it'd be 7. Okay, now how did you get 7?
I took half of 8, which is the difference.
Okay, yeah, there's a couple ways you could do it, but probably most people did it this way because we had already said the length of the segment is 8, right? So the length of half the segment would be 4. And so 3 plus 4 gives us 7, right? Okay, so then what's going to be the midpoint in terms of A and B? What is the midpoint, first of all? What's the length? We already said the length of the segment is B minus A, right?
So it'd be A plus.
Okay, good. So the coordinate of the midpoint would be A plus 1/2 B minus A, right? Everybody see that? So if I wanted to come up with that coordinate then in simplified form, all I've got to do is just simplify that statement. Well, what do I get? A plus 1/2 B minus A. If I distribute the 1/2, what do I get? Minus 1/2 A. What's A minus 1/2 A? So my final answer would just be 1/2 A plus 1/2 B, right?
Or B plus A over 1/2. That would-
Okay, or that. Yeah. Okay. Make sense? Okay, that's all I'm saying. You gotta take it from there. Okay, because now you're just gonna do something additional to that. What you're really trying to find, isn't it, is you're trying to find, like for part A, that's point, is it P is the next one?
Yeah.
That's point P. So now I gotta find the coordinates of P. But I can do that, right? If I could do the coordinates of M, I could do the coordinates of P. Okay? Other questions? Any other questions on 2.5? Belle, you got a question? No? Well, I might give you a tiny bit more than that when we're done, but not much. Not much. Okay, any questions on 2.6? 18? Okay.
Number 7, I kept.
Hey, listen. May I get your attention? This is a little too loud. I'm just not appreciating all the, thank you. Okay, well, we'll be done here soon, and then we'll have some time to do something else. But so the question is, on 18, say it again.
I answered everything on the computer, everything was fine, but I could not get number 7 right.
Number 7.
I have
Oh.
no idea why.
Okay, well, number 7,
Did you use a congruent symbol?
Try to, yeah, copy and paste.
You can use the
Work on Chromebook.
And it doesn't work on.
So how,
It turns into like an E thing.
when you copied and pasted it?
I'm very confused.
Really? Huh.
You have to type in, so the you have to type in Alt keyboard.
I eat all my classes actually.
On a Chromebook? So I'm not sure, did anybody get that to work on a Chromebook? How do you get a? Okay, somebody that did, raise your hand, please. One person talking. Yes,
I just copied and pasted, but then I did it on Brooke's computer and it didn't work.
on her Chromebook?
Yeah, it worked on my
Really?
notebook.
So maybe there's a setting on the Chromebooks that has to be.
Yeah, it didn't work for me.
Does it work on my home computer?
Yeah, it's gonna work on computers fine. You're gonna be able to use the alt codes on computers. Chromebooks, that's something I didn't anticipate. That's a little bit of a problem with Chromebooks.
I did it on my mom's computer, it didn't work.
Yeah, okay, you have to have numlock on.
And my name was like,
You have to have numlock on to use the alt codes. But that's what we're thinking. So you should be able to cut and paste too.
I tried to.
There must be something else wrong with the thing. It should work.
It's a really bad computer.
It's using a modern browser, it should work. Okay, anything else on 2.6?
25, I think is it, might not be 25.
We went through those.
It wasn't 25, it was another problem. I don't know which problem. Oh, it was like 28. I didn't understand what it was quite asking me to do. And it explained my reasoning.
Hey,
What did it
can you
mean?
guys not do that? Say it again.
What does it mean by explaining your reasoning?
You don't have to do that.
Oh, you don't have to.
Okay.
Yeah.
Just solve for it.
Yep, just solve. Anything else? I think we went through everything else.